Hello, and welcome to the Kubernetes podcast from Google. I'm your host, Abdel Sigiwar. This week, I am alone. Kathleen is on vacation, and no one else was available, so I have to do this by myself. This week, I spoke to Kakeru Ishii. Kakeru is the initiator of the Kubernetes History Inspector, or KHI, an open source tool that allows you to visualize Kubernetes logs and troubleshoot issues. We discussed what the tool does, how it was built, and what was the motivation behind open sourcing it. But let's get to the news. The schedule for KubeCon and Cloud Native Con 2025 Maintainer Summit is live. The event in its new format takes place on March 31st at the Excel, London. The CNCF published their 2024 review of the top 30 projects. The ranking measures the projects by number of contributions, and surprisingly, the podium is taken by Kubernetes, followed very closely by OpenTelemetry. Then Argo, Backstage, and Prometheus are all in the top 5. The CNCF is looking for an end-user study to highlight during the keynote of KubeCon and Cloud Native Con London this year. If you have an interesting case and you want to get an opportunity to speak about it for 5 minutes, fill in the form in the show notes. Applications are open until Friday, March 7, 2025. Google, AWS, and Azure announced CRO, or Kubernetes Resource Orchestrator. CRO is a Kubernetes native cloud agnostic framework that allows platform teams to define groupings of resources that users can consume as standard Kubernetes APIs. Check out the announcement blog and GitHub links in the show notes. AWS announced the general availability of AKS hybrid nodes. The feature was announced at reInvent 2024. It allows users to connect on-prem and edge nodes to manage EKS cluster on AWS. The company says this feature could help with modernization and migration of existing applications. CoreWeave announced the availability of NVIDIA GB200 NLV72 instances on their platform. With this announcement, CoreWeave becomes the first cloud provider to make the NVIDIA Blackwell platform generally available. And that's the news. Hello everyone, we are talking to Kakeru today. Kakeru is the initiator of the Kubernetes History Inspector, a new open source project released under the Google Cloud GitHub organization. This project helps visualize logs, and it already helped the support team at Google troubleshoot GKE problems through logs. Kakeru made it using his experience from working at the support team, obviously. Welcome to the show, Kakeru.
Hello, thank you for inviting me to this podcast, Abdel. I'm really excited to be here.
I just have to say, you're based in Japan, right?
Yes, I'm based in Tokyo.
And what time is it for you right now?
It's 5 p.m.
All right.
So I know you are in really morning, right?
It's 9 a.m. for me. It's not too bad.
I'm sorry to wake you up earlier.
It's fine. It's 9 a.m. I am actually, it's funny, I live in Sweden, but I am in the very far north part of Sweden. I'm in a ski resort, very, very far north. So wherever I look, there is just snow everywhere right now.
Nice. In Tokyo, it's rarely see the snows, and I like snows.
Oh, yeah. I have a friend who went to Sapporo, and I think it snows in Sapporo, right?
Yeah, Sapporo is a really cold place, and it's good place for the skiing, maybe. But here in Tokyo, it's relatively warmer than Sapporo.
Got it.
I rarely see snow recently.
Got it. All right. So, all right, let's talk about this tool that you guys have open sourced recently, the Kubernetes History Inspector. Can you tell us what's that?
Yeah, sure. It's a rich log visualizer designed for troubleshooting Kubernetes issues. Before this tool existed, we needed to troubleshoot the pod troubleshoot or something by checking the content log. But if the problem can't be solved content log alone, they needed to rely on various kinds of the logs like kubelet log, container log, containerd log, kube API server log, kube content manager log. There are so many various logs needed to be used in troubleshooting. So it requires high expertise to craft the log filter or something to gather these logs and investigate them, because it's just to generate list tons of the logs. And we needed to understand what's happened in the past around the pod just from the lines of logs. It was so hard for us. So then this tool will provide us a detailed timeline visualization or resource relationship diagram just from logs available on your log backend. Currently, this is only supporting cloud logging, but we are expanding this support to the other clusters, especially for the open source Kubernetes cluster.
Nice. And so one important detail actually that I want to talk about is that it says history in the name, which means that the tool actually allows you to go back in time.
Yes. So when I say that log inspector or something related to Kubernetes, maybe users think this is a kind of agent for tool like Prometheus or something. But actually, this is just a log visualizer. It's visualize the history of the cluster resources just from logs by parsing all of them.
Yeah. Well, we're going to talk about it, but it's important for people to understand you don't need to install anything in your cluster.
Yeah.
I tried this yesterday. I just fired up the Cloud Shell in the console and started the Docker container. And as long as it has permissions to pull the logs, it will just pull them, right?
Yeah.
And give you this rich visualization, as you said. Where did the idea of open sourcing the tool came from?
Well, I'm working as a support engineer in Google, and I needed to troubleshoot customer cluster issues when I got the ticket.
Yeah.
But the problem is, maybe that would be my first day to see the customer cluster. Or even the customer said my port was dead yesterday or something. But when I touch the cluster, maybe the cluster is running healthy without any issue. But the troubleshooting the current ongoing incident is easier than troubleshooting past issue because I can interact with the cluster if customer allow it. However, the troubleshooting past issue require me to see through many kind of the logs, and it takes a really long time. So I wanted to understand the macroscopic view of the cluster.
Yeah.
So that's why I needed to create it. And after I created the prototype, I showed this to my colleague or other support team members, and it gained popularity among my support team or many other teams in Google. And I decided to make this available to the other customers on the internet.
Nice. Yeah, so the tool is obviously is on GitHub. So everybody who's listening to us, you should check it out and maybe give it a little star if you want. It's very easy to start. It's just a Docker container. So I did a little bit of troubleshooting and support back in my days before my current role. And I remember, yes, troubleshooting past problems is difficult, but also troubleshooting problems that doesn't happen very often, right? When you have a transient issue. So how was this tool helps support engineers particularly? How does that help them in troubleshooting these kind of problems?
Well, this is very important for the support chain because the creating the logs is also requiring in the skills. At first, we needed to understand the explicit time or the incident happens. But once this tool was used in support chain, after creating the logs by one support agent, the support agent can show the visualized timeline with the other support engineer handed over. So they will continue troubleshooting with detailed understanding of the cluster.
I see. And so can you talk about some issues that the tool have helped you actually solve, that the Kubernetes History Inspector have helped solve?
Well, let me introduce a little difficult, complex ticket before.
All right.
So this is about the GKE with workload identity, which is a feature to get the access token to access to GCP API from the pod with checking the permissions granted for the Kubernetes service account. So my customer told me to troubleshoot the intermittent error over a workload identity. I mean, customer said, my pod got the authentication error intermittently, but it only happens very few times in the month or something. And I realized that is caused by a third-party security product restarting container D, because workload identity needed to communicate with container D to verify the pod is actually running on the node to return the access token. But to troubleshooting this kind of issue, I needed to check customer pod log, container D log, third-party security product pod log, and also I needed to check the workload identity system workload logs. So the crafting the log query with the checking all the logs would be a little hard. And even if I could get to the list of the lines of the logs, it won't make sense. But this tool will help me to show how these logs happen. And I can see the kind of line of the dots of the logs happening at the same time over the visualization. So I could easily see, this is caused by container restarting or some triggered by third-party security product. So this kind of difficult problem involving multiple components on the cluster can be solved with KHI easily.
Yeah. And so I think what's important in what this particular use case you're talking about is the correlation part. Like how can you correlate events happening in multiple parts of the system using logs and understand that those kind of events are related to each other. Like you're talking about like workload identity, which has its own pod. Then you have the customer pod. Then you have containerd. And then you have the pod of this third-party security tool. And you have to like pull the logs across all these things and kind of like try to understand how they line up with each other, kind of, right? So I was using the tool yesterday, as I said. I fired up the Docker container. I launched the interface. It has a graphical interface, a rather interesting graphical interface because it's built in WebGL. I haven't heard of WebGL for a very long time, but we're going to talk about it. But how does that correlation work? Like, is it the tool that will correlate these things together, or is it you that you have to like try to find that correlation?
Well, is it meaning users needed to customize the correlation settings or something?
Or does the tool find like those events and then says, okay, these events are related in time? Like, how does that work?
So basically, KHI has various various parsers implemented already on its code base. Mm-hmm. So it passed the structured log fields and it decide which resources is related to the logs or something. So, but the log parsers are not such simple. Like some log parser needed to be run before the other log parser or something. For example, containerd log parser shows the container behavior with container ID, but it won't show any pod name or something.
Yeah.
But the kubelet also shows container ID and pod name. So I can correlate the container ID with the pod ID because I'm running the containerd parser after getting the pod name from the other logs. But this is a little hard to, because many parsers depend on the other parsers. So KHI is basically based on the directed acyclic graph. Mm-hmm. It's DAG-based log parser system. So that makes KHI to be extensible. Currently, we are not publishing any document how to extend KHI log parser, but I will do that later. And that helps customer to, extend their log parser to support their own custom control or something.
I see.
And this extensibility makes KHI to support many kind of the logs.
Okay, cool. Yeah, so then I want you to talk to us quickly about how it actually works behind the scene. So I tried it. So it's essentially you start the Docker container. You select, in our case, you select like a project ID. Then you select which cluster you want. Then there is like a little thing happening on the interface that says, I'm running, I'm pulling some logs. And then you get an interface. But how does it actually work behind the scene?
Well, each parser has a dependency of the form. Like, okay, this parser needed to have the project ID before querying or something like that. This dependency is defined on each parsers as a DAG-based graph. So the KHI is just running this graph-based task runner and generate one single log bin file, and then that would be parsed from the front end and show that the diagram.
I see. And as I said, it uses WebGL for the rendering of the interface, right?
Yeah.
Did you learn WebGL to build this, or did you work with WebGL before?
Before joining Google, I was actually I joined Google as a new grad, but my hobby was doing some open source work, especially for the WebGL framework.
Okay.
So I made a WebGL framework before joining Google. So that's why I had experience with WebGL.
I see.
So for me, the usual web development is harder than the WebGL for me because I needed to learn AngularJS to build this application. But for the WebGL side, I know really basic, and I could realize this performant visualization with existing my knowledge.
I see. All right. And so I think I have to ask this question because we are in 2025 and AI is all around us these days. So before I go there, the tool is pretty much in memory only, right? So when you fire up the container, all the logs are in memory, right?
Yeah. Actually, that is intended to be in memory. So if the tool was for the storage, I think that should be done in backend. But I build the application for investigate quickly. So that's why I wanted to take all the logs on the memory on front end side.
Yeah.
That design is intentionally, and that works on the memory.
Nice. And so do you see a future in which an LLM could be integrated into KHI and help troubleshoot issues?
Well, maybe I can consider about it. But the important role of the KHI taking part in LLM, AI era would be like, even LLM said, okay, this problem happened because this configuration issue or something, and this is the intermittent issue triggered by this pod or something. Maybe the people couldn't be convinced so much. So they wanted to understand why that happens with visualization, not just by text.
Yeah.
So that's why this visualization is still important for the LLM era.
I see. Nice. Cool. Well, this is actually pretty cool. So I highly recommend people to go check it out. It's on GitHub. We'll leave the link in the show notes. Go check it out. Go try it out. Give it a star on GitHub. If there is any features missing, either implement it or open an issue, I guess, right? And Kakeru is on Twitter, but your Twitter is mostly in Japanese.
Yeah. So you can follow me, but maybe it's only limited for, no. It will be a little hard for the non-Japanese speakers.
Yeah, so that's fine. Maybe then can talk to you on GitHub.
Yeah.
Yeah, well, thank you for joining us on the show, Kakeru.
Thank you.
That brings us to the end of another episode. If you enjoyed the show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KubernetesPod or reach us by email at kubernetespodcast@google.com. You can also check out the website kubernetespodcast.com, where you will find transcripts and show notes and links to subscribe. Please consider rating us in your podcast player so we can help people find and enjoy the show. Thank you for listening, and we'll see you next time.